Welcome back. In this video, we want to talk about heat pumps, and very specifically, we want to delve a little bit more into the heat and cool cycles and the way the refrigerant flows through the system and the reversing valve. Now, heat pumps move against a temperature rise. In the summer, they move heat from the inside to the outside. In the winter, they move heat from the outside to the inside. As we know, there's always heat in the air outside, regardless of how cold it is, until it gets to absolute zero. The direction of the heat flow is controlled by the direction of the refrigerant flow. Now, that does not mean we reverse the rotation of the compressor. The compressor still always discharges on the discharge line and pulls in on the suction line. So, in conventional refrigeration cooling cycle, heat is absorbed by the evaporator and discharged to the outdoors by the condenser. To change from cooling to heating, the indoor and the outdoor coils need to trade functions. The outdoor coil becomes the evaporator, and the indoor coil becomes the condenser. In the heating cycle, heat is absorbed by the outdoor coil, which is now the evaporator, and it's discharged to the inside by the indoor coil, which is now the condenser. Remember, all we need for heat to move is a warmer area and a colder area. Heat will always move from hot to cold. So this is a conventional cooling cycle, okay? So we have the discharge on the hot gas line comes out of the compressor as a high temperature, high pressure vapor. Then in the condenser, we reject heat to the outside. Okay, and that's labeled number 2 on this slide. We're rejecting heat, and the reason we can reject heat is the condenser is roughly 30 degrees warmer than the ambient temperature around it. And again, so heat will always move from warmer to colder. Then we come out of the condenser as a medium temperature, high pressure liquid. Okay, we've already dropped the temperature, we've changed the state, so now it comes from a gas to a liquid. It comes out through the liquid line. At the metering device, the pressure drops drastically. Okay, the metering device is like putting your finger on the end of a garden hose. So the pressure is going to drop at 0.4. When pressure drops, so does temperature. Okay, this boiling point or saturation point drops. So now I have a low pressure, vapor, easy to vaporize substance that's absorbing heat as it boils off because of the latent heat. Okay, so that happens around point number 5 in your evaporator. So we're absorbing heat from the warmer ambient air around it. Okay, lack of heat means cool. So the evaporator takes that heat out of the air that's being blown across it and absorbs it into the refrigerant. Once the refrigerant has boiled off, we now have a low temperature, low pressure vapor. It's going to gain some sensible heat, which we call superheat, around point number 6. And then it returns to the compressor as a low temperature, low pressure, superheated vapor through the suction line. That's the conventional cycle. Now, let's switch this picture and let's look at a heat pump in a cooling mode, which is the same thing basically. We're just going to add a component. Okay, so we now have a heat pump in cooling mode. Okay, so let's take a look. We come out of our compressor. We come through our new component called the reversing valve, enter on the discharge connection, leave on our outdoor unit connection. We come through the condenser. We condense the refrigerant, losing latent heat. We come through the liquid line. We're bypassing. Okay, we have a bypass valve here. Okay, so we're bypassing first expansion valve. We're coming through and we're forcing the refrigerant through the expansion valve on the indoor coil. Okay, notice that this bypass here is closed. The little ball bearing has slammed against the pipe so that all the refrigerant is forced through the expansion valve. Okay, and then we're coming through the evaporator, boiling off, absorbing heat, coming back through the reversing valve. See this U here? And we're coming into the suction line. So once again, the reversing valve, the compressor always connects to the same two pipes on the reversing valve. The discharge is on the single pipe by itself. The suction is always on the pipe in the center. Okay, that is a heat pump in cooling mode. Now, the coils of a heat pump are typically labeled outdoor and indoor because they are dual purpose. The process is reversed by means of a four-way valve called the reversing valve. Okay, so if I go back here, you see how that this is now in the cooling mode. Discharge to the left. The suction from the compressor does a U basically in the center. Okay, so now this is a heat pump in the heating mode. Okay, so we have our compressor. Our compressor is discharging through the discharge line to the center. Okay, again, because it only connects to two spots, and it comes and goes to the indoor coil because this has now slid over. Okay, this is a little slide part that we talked about in a prior reversing valve video. So now the indoor coil is my condenser. The heat is, this coil is warmer than the air being blown across it because of the high pressure. So heat moves again from areas of higher temperature to lower temperature. That's what's happening in the indoor coil. We come out, we bypass the TXV through our check valve. Okay, then we come to what used to be the liquid, or what used to be the liquid line the other direction. It's now the liquid line reversed, and the check valve going to the outdoor coil is now closed, and it forces everything through the expansion valve that's on the outdoor coil. Okay, and we use the outdoor coil as an evaporator. We're boiling off the refrigerant, absorbing heat into the refrigerant from outside. And then we start our cycle all over again by returning to the compressor. So the only thing that actually reverses flow of refrigerant, okay, is this four-way reversing valve. Okay, so how does the reversing valve work? Okay, all we're doing is using a solenoid coil, which is right here, to operate our pilot valve, which allows the high pressure and the low pressures to push that inside cylinder from either this configuration to the cooling configuration. Okay, this is in a cooling cycle. Okay, so once again, compressor to the discharge center port to my outdoor coil to my evaporator. This is standard refrigeration. During the cooling mode, the high pressure, high temperature discharge gas is directed from the compressor to the outdoor coil, where it condenses to a high pressure, high temperature, subcooled liquid. To avoid the restriction of the metering device connected to the outlet of the outdoor coil, a check valve is installed. This allows the liquid to bypass the outdoor metering device. The liquid travels inside through the liquid line, where the indoor check valve closes, forcing the refrigerant through the indoor metering device. The indoor metering device drops the refrigerant pressure and therefore temperature, so heat can be absorbed as it's boiled off. The refrigerant vapor produced in the indoor coil now travels through the reversing valve to the suction accumulator and onto the compressor. The heating cycle, the refrigerant flow must be reversed for the heating cycle. However, the direction of the refrigerant flow through the compressor is the same. The direction of the flow is changed by the reversing valve, not by the compressor. In the heating cycle, the reversing valve changes positions, changing the direction of the refrigerant flow. The high pressure, high temperature gas from the compressor now flows through the reversing valve to the indoor coil. The indoor coil is now the condenser, adding heat to the space. The hot vapor is condensed and the temperature is reduced to produce a high pressure, high temperature, subcooled liquid. It's actually a medium temperature subcooled liquid. The indoor check valve opens and allows refrigerant to flow to the indoor metering device. Continuing through the liquid line, the liquid refrigerant is forced through the outdoor coil metering device by closing the outdoor check valve. The refrigerant flows through the outdoor coil, which is now the evaporator. The low pressure keeps the refrigerant temperature lower than the outdoor temperature, allowing the coil to pick up heat from the outdoor air. The refrigerant then flows through the suction line, the reversing valve, the accumulator, and back to the compressor. So again, this is a heating mode diagram. Okay? Notice the outdoor coil, okay, is connected to the suction line of the compressor through the reversing valve. The U basically on that reversing valve is that is the reversing valve slide component that changes. The indoor coil is now getting the discharge gas from the compressor. We reverse it to the cooling mode. The reversing valve shift position. Notice my U is now on the connecting the indoor coil to the suction line, and my discharge gas is going to the outdoor coil. Okay, we're rejecting the heat to outside. We're absorbing heat from the inside. The liquid line, the liquid refrigerant, has reversed direction.